All right. Took Claritin, and Cat is sated, at least for the moment. Although it's raining, so she can't nap in the sun, so we'll see. I may get distracted again here in this one. But two more problems left here for the end of the chapter. So we want to calculate the molar concentration of hydroxide ions in a 0.550 molar solution of hypobromide ion. So hypobromide ion, negative charge, lone pairs on the oxygen, right? That could react with H plus to reform the acid there, which would be hypobromous acid. So weak base, we're given the Kb, right? We just want to calculate the pH. So given that ion, we should be able to write out what would happen if it acts as a base with water. So bases grab protons, so that would be HBRO, aqueous, and take a proton away from water and you get hydroxide ion. Slap this ice chart on here. The initial concentration is 0.55 molar. No products under initial conditions. So not a minus. We're going to lose some of the reactant, gain some of the products by equilibrium. This would be 0.55 minus x, x, and x. Now again, can we eliminate this x? Right? We want to compare, in this case, the concentration of our weak base to its Ka, sorry, Kb. Excuse me. So 0.55 divided by the Kb, 4 times 10 to the minus 6th. That comes out to be 0.55, calculator shut off, 0.55 divided by 4 times 10 to the minus 6th, 137,500. So yes, this is perfectly reasonable to make the assumption that we can remove that x and that will not have a big effect on what we end up calculating here. So plug into our Kb expression here. So products over reactants. Right? This should be kind of old hat at this point, setting that up. Kb was 4 times 10 to the minus 6th. Both of the concentrations on top we called x, so x squared over 0.55. Once we make the assumption and remove that x. So rearrange that to solve for x. We can do that right in the calculator fairly easily. 4 times 10 to the minus 6th, multiply through by the 0.55. And then I'm going to take the square root of both sides. So square root of my previous answer. X is 1.48 times 10 to the minus 3rd, right? And that's a molarity. Right now, based on the equilibrium we're looking at, this is hydroxide ion. So that's the concentration of hydroxide ion. That means we can get to the pOH by taking the negative log of that concentration. So if I do that, negative log of my previous answer, the pOH here is 2.83. So if the pH is 2.83, then if I subtract that from 14, I get pH here being 11.17.